6.4 is over independent and dependent events. So the learning target for this lesson is to understand and find probabilities of independent and dependent events. So by doing that, you're going to explain how independent and dependent events are different. You can determine if they're independent, and then finding the probabilities of those events. So the first thing that we're going to go over is determining whether events are independent. So two events are independent events when the occurrence of one event does not affect the occurrence of the other event. So if one event can happen and it has no effect on the other one, then they're considered independent. The probability of independent events. So two events A and B are independent events if and only if the probability that both events occur is the product of the probabilities of the events. So P of A and B equals P of A times P of B. The way that you can think about this is like if I roll a dice and then I flip a coin, those are two completely independent events. And that's why earlier when we did, I think it was in 6.1, if I wanted to find the probability of both of them happening, I would just multiply the two probabilities. All right, so example 1. A student taking a quiz randomly guesses the answers to 4 true or false questions. Use a sample space to determine whether guessing the correct answer to question 1 and guessing the correct answer to question 2 are independent events. So we're going to make the sample space. This is kind of the same thing as what we did before, I think, but the different outcomes. Remember, we had our table with our different outcomes to show our sample space, but you can get 0 correct, and that would just be all incorrect. You could get 1 correct, so you could get the first one, the second one, the third one, or the fourth one. You could get 2 correct, so you could get the first 2. You could get the last 2. You could get the first and last. You could get the middle, or it could alternate. You could get 3 correct, so first 3, middle 3. Oh, I am writing entirely too many letters right now. Okay, middle 3. Why can I not write right now? There's no middle 3. Why do I keep saying middle 3? Last 3. Or your incorrect could be embedded in them. Gosh, okay, there we go. Or you could get 4 correct, so all 4 correct. Okay, so in my sample space, we gotta find first the probability that they would get the correct answer to question 1. So probability that they are correct on question 1. So total, I know there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then the ones where I got question 1 correct, that's this one, 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 and this one. So there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 where I got question 1 correct. We'll simplify that, so that'll be 1 over 2. Okay, then we want to find the probability that they got the correct answer to number 2. So again, over the total 16. So number 2 correct, we've got here, 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 here. Okay, I've highlighted all the ones where number 2 is correct. So that is 1, 2, 3, 4, 5, 6, 7, 8. So 8 over 16. That also simplifies to 1 over 2. Then we want to find the probability that they were correct on both. Question 1 and question 2. So I'll use red. So just the ones where question 1 and question 2 are this one, this one, this one, and this one. The ones where I've highlighted it twice. So that is 1, 2, 3, 4 out of 16, which simplifies down to 1 over 4. And then we're going to check using this right here, P of A and B equals P of A times P of B. So P of A and B is 1 over 4. And then I want to check and see, does that equal P of A, 1 over 2, times P of B, 1 over 2. And so we simplify, 1 over 2 times 1 over 2 is 1 over 4. So yes, they are independent. All right, example 2. Determining whether events are independent, so another one. A group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Use a sample space to determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. So we got 1 boy and 3 girls. So no matter what, the boy, it's just going to be 1 boy. So we're going to set up a table. This time we're going to count number of girls. And we're going to list the outcomes for that. So there obviously has to be 1 girl, right? Because there's only 1 boy. So if there's 1 girl, we can have the boy and girl 1, or girl 1 and the boy. We could have the boy and girl 2, or the girl 2 and the boy. And then we could have the boy and girl 3, or girl 3 and the boy. Okay, if there's 2 girls, then we could have girl 1 and girl 2, or the opposite direction, girl 2 and then girl 1. We could have girl 1 and then girl 3, or girl 3 and then girl 1. Or we could have girl 2 and then girl 3, or girl 3 and then girl 2. So those are my different outcomes. Now we're going to figure out if the probabilities are independent, or if the 2 events are independent. So the first probability is randomly selecting a girl first. So probability of a girl first. So I'm going to look at all my ones where I have a girl first. Obviously all the girls. So total I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. And then I have 1, 2, 3, 4, 5, 6, 7, 8, and 9 where I chose a girl first. I'm going to simplify that, so 9 over 12, divide both by 3, get 3 over 4. Then I want to find the probability of choosing a girl second. So again, that'll be over 12, and I will use a different color to highlight here. All right, so girls second, I have here, 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 and then all of these where I have a girl both times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that also simplifies to 3 over 4. Then we want to find the probability of both. So probability of a girl first and a girl second. So I'm looking for all the ones where I have both highlighted, basically, which is all the bottom row. So 1, 2, 3, 4, 5, 6. That simplifies to 1/2. And then we want to check and see if I multiply the probability of A times the probability of B, does that equal the probability of both? So 3/4 times 3/4 is 9 over 16. That does not equal 1/2. So no, these events are not independent. All right, you can also determine whether two events are independent using conditional probabilities. When two events are independent, the conditional probability of A given B is equal to the probability of A, and the conditional probability of B given A is equal to the probability of B. So for example 1 and example 2, or for example 3, we're going to look at example 1 and example 2 using conditional probabilities. So for part A, looking at example 1, we got to figure out, is the probability of A given B the same as the probability of B? So looking back at example 1, probability of A given B hold on, sorry. I am confusing myself right now. We're going to do probability of B given A. Sorry about that. Okay, there we go. So my events, this was A, this was B, this is A and B. So remember, if you want to find the probability of B given A, you're taking the probability of A and B. So for this one, that's 1 over 4. Over the probability of A which we found was 1 over 2. So remember, keep, change, flip. So keep, change to multiplication, flip 2 over 1. We're going to simplify that. So 1 times 2 is 2, over 4 times 1 is 4. That simplifies down to 1/2. So that's probability of B given A. And then we're going to check and see, does that match probability of B? So we're going to go back up to example 1. And I saw my probability of B as 1/2. So yes, they do match. So yes, because the probability of B given A equals the probability of B, these events are independent. All right, part B. We're going to find the same thing, probability of B given A. Does that equal the probability of B? So probability of B given A for example 2. Again, this is A, B, A and B. So A and B is 1 over 2 over probability of just A is 3 over 4. Keep, change, flip. So 1 over 2 times 4 over 3. So 1 times 4 is 4. 2 times 3 is 6. We can simplify that to be 2/3. And then the probability of B, for example, 2, we found was 3/4. So those two numbers do not match. So again, we found that these events are not independent. Because P of B given A does not equal P of B. All right, self-assessment problems. Pause the video for about 5 minutes and work on these self-assessment problems. Okay, let's check these self-assessment problems. So for number 1, in example 1, determine whether guessing question 1 incorrectly and guessing question 2 correctly are independent events. So this will be A, this will be B. You can use either method. So if you want to use the conditional probability, you can. If you want to use just the probability, you can. I'm going to do both. So for problem 1, I'll do probability. So we're trying to figure out, does the probability of both equal both probabilities being multiplied? So probability of both, or actually probability of A, which is question 1 incorrect. So I'm going to go back to example 1 and find all the ones where question 1 is incorrect. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 out of the total 16. Which is 1/2. Then I'm going to find the probability of B. Question 2 correct. So I'm going back to my example 1, and I'm figuring out how many outcomes are question 2 correct. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So again, 8 out of 16, that's 1/2. And then the probability of both. So all my ones were question 1 is incorrect and question 2 is correct. So I'm looking where I have an IC to start. So 1, 2, 3, 4. So 4 out of 16 have both question 1 incorrect and question 2 correct. Simplify 4 over 16, you get 1 over 4. And then we check, does 1 over 2 times 1 over 2 equal 1 over 4? And if I multiply those, I do get 1 over 4. So yes, these are independent. All right, number 2. Determine whether randomly selecting a girl first, that'll be A, and randomly selecting a boy second will be B. All right, so probability of A, girl first, going back up. Girl first, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I forgot the total. Total is 12. Okay, so 9 out of 12. Which simplifies to be 3 over 4. Then we're going to find the probability of B, selecting a boy second. So I'm going back up. How many boys are second? So I have 1, 2, 3, where I have a boy second. So 3 over 12. Gonna simplify that. That'll be 1 over 4. And then I'm gonna find probability of A and B. So girl first, boy second. So I'm looking for all the ones that have GB. So that's 1, 2, 3. So 3 over 12 is 1 over 4. For this one, I'm going to use the conditional probability. So P of B given A that's my P of A and B, 1 over 4, divided by my P of A, 3 over 4. Keep change flip, so 1 over 4 times 4 over 3. That'll be 1 over 3. And then does that match P of B? Which it does not. So these are not independent. All right, for the sake of time, I'm going to skip number 3. But if you got to number 3, you should have found that these are not independent. So you would have had to write out your sample space, find your probability of A, find your probability of B, find your probability of both, and then determine from there. All right, so example 4. We can also use a two-way table to determine independence. So a satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results given as joint relative frequencies are shown in the two-way table. Determine whether recommending the provider to a friend, and living in Long Beach are independent events. So the way that I'm going to do this is I'm going to use the conditional probability formula, P of B given A equals P of B. And so P of A is Long Beach. Oh. Nope. A is recommending. B is Long Beach. So probability of B given A, Long Beach, given yes, they would recommend, is the probability of both. So Long Beach given yes, 0.32. Over the probability of them saying yes. So all of these values right here added together, we got to find the total. So 0.29 plus 0.27 plus 0.32. So I'm going to use my calculator. And I'm going to say 0.29 plus 0.27 plus 0.32, so 0.88. So we got 0.32 over 0.88, which we will use our calculator to solve. 0.32 over 0.88. So that's about 0.36. And then we're going to say, does that match the probability of B? So this is B given A. And then probability of B is the probability of Long Beach. So there we're looking at these two numbers, 0.32 plus 0.04. Which is 0.36. And so yes, those two do match. So yes, the two events are independent. Okay? Pause the video for 3 minutes and work on self-assessment number 4. All right, you should have worked on number 4. So we're going to find, we've got determine whether recommending the provider to a friend, A, and living in Santa Monica, B, are independent. So we're going to again find probability of B given A. Does that match probability of B? All right, so probability of B given A, that is the probability of Santa Monica given yes, they would recommend. So Santa Monica and yes is 0.27. Over all the yeses we already found are 0.88. So 0.27 over 0.88. That's about 0.307. Okay, and then we're going to find the probability of B, so just Santa Monica. So we're adding everything in Santa Monica. That's going to be 0.27 plus 0.03. And that's going to be 0.30, which, yes, those are close enough to say that these are independent. All right, so that is all for determining whether two events are independent. Once you have determined if some two events are independent or dependent, the next thing we're going to do is find the probability of independent events. So if you think about it logically, I mean, you can make sense of if something is independent or dependent a lot of the time. Like in example 1, it makes sense that they're independent because if you are guessing on a test, your second guess is not affected by your first guess. In example 2, it makes sense that they are not independent or they are dependent because when you're selecting people and you pull one out of the group, then suddenly you're changing the group. So your next pick depends on who you picked the first time. So two events are dependent when the occurrence of one event does affect the occurrence of the other. And we're not going to determine if something is dependent, but we are going to find the probability of independent and dependent events. So our first example is just the probability of independent events. So in this example, a spinner is divided into equal parts. Because the spinner is divided into equal parts and I'm not taking away part of the spinner each time I spin, I know that this is independent. And so what I'm going to do is I'm actually going to find P of A and B. So I'm going to think back to the beginning when I said P of A and B. That's going to equal P of A times P of B. So find the probability that you get a 5 on your first spin, so A, and that you get a number greater than 3 on your second spin, so that'll be B. So probability of A, that I get a 5, I don't know why my iPad's doing that, that I get a 5 on my first spin, there's only one 5 out of 8 total sections. So that'll be a 1 over 8. The probability of B, so that I get a number greater than 3, that's going to include 4, 5, 6, 7, and 8. All of these sections. So that's going to be 5 out of 8 sections. So I'm thinking back to that formula that I was just writing. I wrote at the bottom. If I want to find the probability of both of these, since they are independent, I'm going to take probability of A, 1 over 8, and multiply it by my probability of B, 5 over 8. So 1 times 5 is 5, over 8 times 8 is 64. Convert that to a decimal, over 64, about 0.078. Or about 7.8%. All right, my next example. If it is dependent, I'm going to use my formula that was just given to me here. So P of A and B equals P of A times P of B given A. So I'm going to make that note here. P of A and B equals P of A times P of B given A. All right, so a bag contains 21 $1 bills and 5 $10 bills. You randomly draw a bill from the bag, set it aside, and then randomly draw another bill from the bag. The part that makes this dependent is that you take something out, you set it aside, you are changing how many things you have to choose from now. So that's what makes it dependent. Find the probability that both events A and B will occur. So they gave us event A and event B. Event A, the first bill is $10. Well, I have 25 bills total. And the chance of me pulling a $10 bill, I have 5 of them. So 5 out of 25. Gonna simplify that, divide both by 5. That'll be 1 over 5. All right, probability of B given A. So when I already pull out a $10 bill, now I have 24 bills left. I still have 21s, but now I only have 4 10s. So now the probability that I pick a 10 as my second bill, I've got 4 10s left out of my 24 total. And I'm going to simplify that by dividing both by 4. So that'll be 1 over 6. And so now to find the probability of both A and B happening, I'm going to take probability of A, 1 over 5, times the probability of B given A, 1 over 6. So 1 times 1 is 1, over 5 times 6 is 30. So 1 over 30 is about 0.033. Or about 3.3%. I am sorry about my dogs today. All right, pause the video and take 4 minutes and work on number 5 and 6. All right, let's work on number 5 and 6, or let's check number 5 and 6. Number 5, in example 5, what is the probability that you spin an even number and then an odd number? So number 5, looking at example 5, we already determined that they're independent. So I'm going to make a note right here. These are independent, which means I'm going to use the formula P of A and B, the probability of them both, is just P of A times P of B. So A is an even number, B is an odd number. If I look at my spinner, I have 1, 2, 3, 4 even numbers. So P of A is 4 over 8, which simplifies to 1 over 2. P of B, probability of choosing an odd number. Hopefully you don't have to look at the spinner, but just in case, that's 1, 2, 3, 4 odd numbers. So another 4 over 8, which is 1 over 2. The probability of both, I'm going to multiply P of A times P of B. So 1 over 2 times 1 over 2 is 1 over 4, which is 0.25 or 25%. All right, number 6, in example 6, what is the probability that both bills are $1 bills? So again, we have already determined that this is a dependent event, which means that to find P of A and B, I'm using the formula P of A times P of B given A. So probability of A is that I pull a $1 bill first. So I gotta look back at my scenario. I have 21 $1 bills out of 25 total bills, so 20 out of 25. Simplify that by dividing both by 5. That'll be 4 over 5. which is 0.8, or 80%. The probability of B is that we pull a $1 bill after A happens. So after A happens, I take away one of those $1 bills. So I'm left with 19 $1 bills. I still have 5 $10 bills. So now the probability that I pull a $1 out now is 19 over 24. I can't simplify that at all. Oh, and then I wrote that wrong. That's probability of B given A. Let me fix that. Okay, so using my formula, I don't know why I found the decimal here. You do not need to find the decimal for that. All right, using the formula, the probability of them both happening is the probability of A, 4 over 5, times the probability of B given A, 19 over 24. So 4 times 19 is 76 over 5 times 24 is 120. I know I can divide those both by 2. Let's see if that's the smallest it'll get. So 76 divided by 2 is 38. That's definitely not the smallest it'll get, so let's try 4. 76 divided by 4 is 19. Yep, okay, so divide both by 4. So 19 over 30, which then I'm going to simplify that as a decimal, or write that as a decimal. So 19 divided by 30 is 0.633. Or about 63.3%. All right, that is it for 6.4.